AI is transforming how we build and deliver software, but behind every model and every pipeline is an operational challenge that is unlike anything we have seen before. From GPU clusters to data orchestration, the ops for AI world is forcing teams to rethink infrastructure automation, cost, and scalability. Today, I'm joined by once again Rob Hirschfeld, CEO and co-founder of RackN, to unpack what makes AI operations unique and how organizations can prepare for this new wave of complexity. I saw your case study about AI clusters as a service. Can you recap what that's about and what problem you were solving for the customer?
It really is a stunning study overall in just how expensive the AI infrastructure is and how complex it is. So what we did, we got pulled in to help a major service provider who is offering an internal training clusters as a service offering internally. And they have a demand to allow individual teams inside their organization to have access to a 64 machine training cluster. It's a $250 million overall investment for these machines. Incredibly complex networking and storage configuration. And they need those to be offered as a service. So that means that somebody's going to use those, run a training job. They have to certifiably clean those systems so no data is left, so there's no chance of leaking data between training runs, and then reset it and turn it back over to the next customer. That's the use case, and they have hundreds of these clusters being built. They're building even more footprint and capacity over the next year, and we were able to get the reset time using digital rebar down to 90 minutes. So that's a complete scrub of the system, wipe all the disks, make sure that everything is completely cleaned up, apply whatever patches are necessary to the systems, rebuild all the networking topology and configuration, set all of the configuration and BIOS. So they not only do a reset, they also clean, patch, and update the systems. Since each machine is incredibly specific to its location in this fabric network, you have to put it exactly back into the right fabric, even after you've patched the NICs. Then reapply the operating systems. They'll build Kubernetes clusters internally, and that gets handed back over to these teams. So the entire reset time takes 90 minutes to do. It's absolutely jaw-breaking. Before doing this manually, we've seen a week is usually the best operation, even with a degree of do-it-yourself automation. It's $150,000 of idle time just in depreciation of the gear, not even to mention the lost ROI, what you're not doing with those systems, right? The power that they're burning, and the fact that you would need more clusters to support the teams with that type of reset time. So a 90-minute reset time gets you back in basically the time it takes to rebuild a Kubernetes cluster on the cloud. We're actually turning over these whole AI systems. So incredibly powerful story about just how effectively, with the right automation, you can deliver AI systems.
RackN works with customers who are dealing with much more complex operations. But if we just look at AI, what makes AI operations so uniquely challenging compared to traditional DevOps or cloud-native workloads?
One of the funny things I think, my CTO, Greg Althouse, would tell you there isn't anything particularly unique about AI operations. It's important to note, right? This customer is using digital rebar pretty much out of the box. They've added some capabilities, which all of our customers do, but they're using our standard pipelines. So fundamentally, what they're doing is bare metal operations. The thing that makes AI really harder is there is a much more complex networking topology. You have a hybrid of InfiniBand, fiber channel, Ethernet networking all mixed together in how these systems work. And the network topology itself is much more sensitive. So in these training clusters, like in any AI training cluster, there's a lot of peer-to-peer traffic, and there's a configuration in the networking where you're talking with redundant switches, redundant connections. You've got a NIC that has to be patched on a regular basis. You have systems that have incredibly complex and demanding BIOS demands. All of those things are true in any systems we deal with. But in the AI infrastructure, with the incredible pressure on the cost of the machine and the demand for the actual server to be in production, those things are amplified in an AI system. They're not actually that different than what we deal with on a regular AI basis. You and I talked about a process where we do a clean wipe and reset to allow systems to be decommissioned automatically. All of those technologies are really built into the product. And so they're normal processes. The pressure and the price are things that are really higher.
And is it more about scale, unpredictability, type of hardware, data pipeline, privacy, compliance? What makes these workloads different?
That's one of the things that makes AI hard. It's about all of those things. You don't get a break here, right? The AI builders and the pace at which we're building AI clusters, right? The other thing that's really notable is that this customer is able to onboard gear in 4 hours. So they get new clusters shipped. They're able to get them completely qualified, tested, burned in, and validated and ready to go in just 4 hours. That in itself is also groundbreaking. That means that they're not wasting time getting systems racked. They're not worried, right? They get delivered racks. Everything's pre-integrated. Once they turn on that gear, it's ready to go. That type of aggressive go-to-market is also the hallmark of these AI companies. They're trying to compress time so much because they're paying, they're buying the gear. You can't afford to let that gear sit idle, and things are moving so quickly, it's a competitive advantage. So every minute you have where the systems are in use, that becomes tremendously powerful. It's the same thing that we're seeing with any of the neo clouds or this new generation of AI service providers. Going from having a GPU offering, I can give you a GPU and it's going to take me a week, or I'm going to have spare capacity. That's really unacceptable, right? This isn't, it's funny. There's so many dimensions here. It's just a capacity problem. If you have clusters that are going to have a 2-week cluster training time, but you have to spend another week setting that up, that's a 50%. You need 50% more capacity to offer the same capability. So, there's tremendous components in cost and management and governance. The patch levels, the rate things are changing, all higher. But it's the same thing, just faster.
You mentioned that Kubernetes is being used in AI, but not always in the way people expect. Can you explain how AI workloads are both similar to or different from the traditional Kubernetes use cases most teams are familiar with?
We see Kubernetes as the underlying training orchestrator for these jobs, right? Very famously, Run AI, which was purchased by NVIDIA, they rely on Kubernetes as the underlying training. And we've seen the same thing in public presentations by CoreWeave, et cetera. It is very much being used to manage the jobs that are going onto these systems. The thing that's different, though, is that whether for training or inference, we really have a very different storage configuration because you have a lot of data to store. For training, you have to be able to save checkpoints. We have a different networking topology. And so in a traditional Kubernetes mindset, a very cloud native mindset, all of the machines in a Kubernetes cluster are interchangeable. They're disposable. You just throw out one, you get another one. You don't care where it comes from. You're not very worried about its networking, its topology, or its storage. In AI workloads, and the same is similar in a virtualization workload, by the way, you care about networking, placement, location very deeply. And so when you're dealing with these machines in a Kubernetes context, you have to provide the information so that that node in the cluster gets set up correctly. It gets wired back into the cluster, it gets tagged, and the information comes in appropriately so that the system comes up. You can't just deal with them as individual nodes. You can't just say, I'm going to, ask for a new AI training node because this one failed. It is a dedicated cluster with a specific purpose. And you don't want them sitting idle waiting to be allocated in a cloud model. You need to build the whole cluster and then run the cluster. And then each node in that cluster is managed over the life cycle in that cluster. So a lot of the ways people think about infrastructure underneath Kubernetes in a very dynamic cloud pooled reservation model just doesn't apply in these instances, right? In some ways, it's a simple math. The gear is way too expensive for you to have an idle pool of AI machines waiting to be allocated. But even if you did that, they wouldn't be networked correctly. And so what we see in this use case, and also in the virtualization use case, is that you're buying the infrastructure you need to run the cluster. And then you deploy the machines for that cluster. If you're going to update or patch a machine, you're going to basically do an in-place update or a swap, and then you have to be able to do that reset. So all of these pieces fit together more in a sort of a more traditional cluster, infrastructure mentality than you might get if you were thinking of the way we use Kubernetes and cloud infrastructure.
Let's talk about the economics of automation for AI. With massive compute and GPU cost, how does automation impact the total cost of ownership or ROI for organizations who are deploying large AI models?
Boy, I love this question because there's so many dimensions of cost here. And the simplest one is just faster time to value. It's can you keep the machines up? Can you keep them patched? Can you keep them running? Can you do a reset faster? There's a lot of just using the gear more effectively, because cost in an AI infrastructure is actually lost opportunity. Opportunity cost is a much more significant part of AI costs than the infrastructure costs. That's why people are willing to spend so much money buying these servers. And it's also worth noting that one of the things that we've demonstrated over and over again is the ability to be vendor agnostic, to be heterogeneous about which vendors are being supported and how they're being supported. So we see very much that our customers switch hardware OEMs. They might buy Supermicro because they have an advantage and then switch to Dell or HP, Lenovo, Cisco. All right. The ability to swap vendors in and out, depending on capability of the gear, but also cost differential from a negotiation perspective, is dramatic in how these systems go. And we're seeing in market tremendous pressure on alternatives to NVIDIA. And so the ability to mix in Ethernet and so RockE or NVIDIA InfiniBand, mix those different types of network topologies, mix your training infrastructure, right? So NVIDIA or AMD processors, being able to be heterogeneous in that is absolutely essential in market. And there is no single bigger driver of cost savings as being able to have a competitive infrastructure. And so what we're seeing right now, and we're helping customers do, is not just build the traditional NVIDIA footprints, but we're starting to see this trend line of investigating Ethernet as an alternative, AMD as an alternative, right? Those are incredibly powerful drivers at cost and frankly, availability of infrastructure.
Let's talk about how to get started. When companies start building or start scaling their AI infrastructure, what should they be thinking about from day one?
Yeah, we unfortunately see a lot of customers who are very hesitant to jump in because they're worried about buying the right thing. You're spending so much money that, the concern of, did I buy the right machine? Is it going to be, aged out, or the last generation even before I bought it? What we really, really strongly suggest customers do is worry less about what they're buying and more about their AI, their configuration, their automation, the pieces, and how they're doing it. What I have seen, and it's really sad, is we've seen customers who buy a certain amount of AI gear and then spend a lot of time manually setting it up and configuring it and trying to make it work. We see the similar thing in people trying to leave Broadcom and having to go through this learning process. If you start the learning process by hand, figuring you have to learn how to do all of these operations, you're really wasting a lot of time. That's not the important thing, right? We really help customers get running much faster. So they're already doing cluster builds, repeated cluster builds. That type of apply, rinse, repeat cycle is much more important than trying to figure out how your drivers work in these different integrations. And customers lose a lot of time trying to figure that out. And the simple reality here is, by the time they figured out how to do it with one thing, it's going to have changed. That is not valuable knowledge to accumulate. It's just moving so quickly. What really helps is you want to build processes that are fast, resilient, and iterative, and then be able to move through your learning cycles much, much faster. So you have to build that at the beginning of this cycle, and then that will make you more confident that, you're never going to buy exactly the right thing, but that what you buy, you can change and pivot it and adapt. That's really the only secret for moving more quickly in AI.
And if I ask you from a very, very strategic point of view, is it about hardware abstraction, automation frameworks, multi-cloud considerations? What are the considerations they should have in mind before they get started?
Yeah, there aren't a lot of abstraction frameworks that you can use from an AI perspective. We're starting to see some good inferencing platforms come in that are cross-machine, right? We're using Kubernetes already, and people should be familiar with that. Although we're using it differently. We're thinking of Kubernetes, from an infrastructure perspective rather than a cloud perspective. But fundamentally, those are sort of things you have to work through and learn. It's just part of the challenge.
Of course, I'm not going to ask you to talk about 5 years from now, but where do you see AI ops heading in the next couple of years? Will it merge with traditional platform engineering, or will it become its own distinct discipline?
Yeah, I'm glad you're asking me about AI ops. There's multiple levels here in how we think about this. Usually when people say AI ops, they really mean the process of managing and feeding the cluster once it's been built. So that's really, a platform team, an AI platform team that's supporting the feeding and managing the platform, running jobs and things like that. I do think that's ultimately a platform team merger. It's a very similar capability. You're using a similar abstraction above. One thing we see really missing from the discussion is an AI infrastructure operations discussion, where we're really talking about how we build operations and automation on AI infrastructure, what types of things you have to think about, how you build the machines, what type of patching and management and networking, all those topology things. That's something that's right now only being done by, really the largest users of AI, and it's very much closed door type of conversation. So we see that, there's a wave coming of more enterprise users where they have to think about how they operationalize AI infrastructure. And that's a conversation that we're in with many of our customers, and we're working through that process. And we will, as part of our normal engagement in our communities, be describing it and helping normalizing it and explaining what we do as part of our normal tech ops training series and how things work. There's another piece in here about using AI in operations that I think is very interesting, where we talk about either building MCPs or doing vibe coding or vibe ops coding, if you will. Those things we are also investing in, and we're starting to explore how we can make people consuming infrastructure actually start leveraging LLMs, coding assistants, and things like that to do their operational work on top of these systems. There's a whole conversation about stochastic versus deterministic systems that goes under this, and the difference between trying to build complex infrastructure and automation with AI, which I think is very hard and challenging, versus using an infrastructure abstraction with AI, which we're seeing some promising results from.
And before we wrap this up, I would also like to know, what role do you see of RackN in this AI-driven world?
We see this as a tremendous opportunity. The capabilities we have out of the box, as we've talked about, apply immediately into this infrastructure space. We are transforming the delivery pace for our customers in infrastructure, AI infrastructure specifically. That's why I'm so excited to talk about this case study. And we see the ability to leverage AI more efficiently and get that infrastructure in use quickly and turned is actually a big part of helping save energy, of helping save money, using the infrastructure faster. And what we've watched in industry is a lot of people show up in AI data centers and they don't have that enterprise operational experience that is so applicable to these systems, and then spend months bringing on systems, weeks patching them, very frustrating for their customers, very frustrating internally. And so we see RackN and Digital Rebar as really transformative in bringing the type of process and automation that we've brought into the enterprise and into leading AI consumers into a more general market. That's fundamentally what we do. This is such a huge, we're only at the beginning of the wave for AI. We believe very passionately that AI will be democratized, that companies will be running their own models. They need to run their own models, whether it's at the edge or in their own data centers or for data sovereignty reasons. And so what's going on for training and frontier models and the inferencing that's being done by those large companies, that will ultimately make its way back into every enterprise. It's a little scary because right now, the infrastructure is very expensive, but we believe competition will also bring that down. And our mission is to make infrastructure ownership and management accessible to everybody. And that AI is going to be the leading indicator of that.
Rob, thank you so much for joining me. This was, as usual, a great deep dive into what it really takes to operate AI infrastructure at scale. So thank you for sharing those insights, and I look forward to chat with you again. Thank you.
I appreciate the thoughtful questions. Thank you.
And for those watching, if your team is building out AI clusters or rethinking automation for the GPU era, definitely check out RackN's work and resources. And as always, don't forget to like, share, and subscribe to TFIR for more conversations with the leaders shaping the future of AI infrastructure. Thanks for watching. See you next time.